So this is part 247, line 22E6. If you're looking at line 22, you want to start with line 22A and then go from there. All of these videos are connected to each other, okay? So this is line 22E6, carbon fusion cycle, helium nucleus, nitrogen 15, UFO 5G Wow Seti. I got the word nitrogen 15 from one of our viewers. They left a comment for me to do some research on it, so I created this particular lens because he wanted to know about it, or he suggested it, sorry. So there's the alien radio signal. June 13, 2012, he made a comment on the line 18A4E, helium-3 alpha particle decay tritium U238 PU239 nuclear fusion engine 5G Wow Seti. The comment received was about carbon-nitrogen 15 fusion. So I've Googled to see what comes up. Today is June 24th. So I found this cycle here. It talks about carbon 12 switching to 13, carbon 13, nitrogen 14, oxygen 15, nitrogen 15. Okay, so that's the cycle, how it creates it. The main theme of the carbon cycle is the adding of protons. But after a carbon 12 nucleus fuses with a proton to form nitrogen 13, one of the protons decays with the emission of a positron and a neutrino to form carbon 13. Two more proton captures produce nitrogen 14 and then oxygen 15. Another neutron decay leaves nitrogen 15. Another proton capture produces oxygen 16, which emits an energetic alpha particle to return to carbon 12 to repeat the cycle. This last reaction is the main source of energy in the cycle for the fueling of the star. So I was thinking, never mind, I won't tell you because then I'll tell you my thoughts before I tell you my thoughts, you know. I keep doing that, sorry. While this process is not a significant part of the sun's fuel cycle, a star like Sirius, with somewhat more than twice the mass of the sun, derives almost all of its power from the carbon cycle. The carbon cycle yields 26.72 MeV per helium nucleus. And that's from hyperphysics.phy-astr.gsu.edu. Okay? So June 13, 2012, my thoughts. A formula idea from this data. We take carbon, add cycle, plus protons, plus carbon 12, plus nucleus, plus fuses, plus nitrogen plus nitrogen minus 13, plus proton decay, plus emission, plus positron, plus neutrino, plus forms carbon minus 13, plus 2 proton captures, plus nitrogen minus 14, plus oxygen minus 15, plus neutron decay, plus nitrogen minus 15, plus proton capture, plus oxygen minus 16, plus emits, plus energetic, plus alpha particle, plus return, plus carbon minus 12, plus repeat cycle, plus last reaction, plus source, plus energy, plus fuel, plus star power, plus carbon cycle, plus 26.72 MeV per helium nucleus. So I'm going to Google helium nucleus nitrogen 15, and this is what came up. Atoms, the inside story, isotopes and decay. Resources, schoolscience.co.uk. The nucleus of an atom contains protons and neutrons, and it counts for nearly all. Some nitrogen atoms have 15 nucleons in the nucleus and therefore have an atomic. We know that the nucleus of helium is 1.9 by 10 to 15 meters across. CNO cycle nuclear fusion. Britannica Online Encyclopedia. This is from Britannica.com. Eventually, the nitrogen 15 nucleus captures a fast-moving proton, breaks down into a carbon minus 12 nucleus plus a helium nucleus alpha particle of mass 4. Now that right there, that tells you how you can take the carbon formulas and use it to recycle the energy, and you would use that in your jet fuel propulsion system. Quote, stellar processes in evolution, nucleosynthesis. Nuclear fusion, where nuclei combine to make a nucleus with a larger number of protons and neutrons, occurs in a main sequence stars once they reach a critical temperature. This air conditioning is killing me today. Dust keeps choking me. Sorry. As the core temperature rises, due to ongoing core contractions and resulting increase in pressure, the atomic nuclei move faster, thereby increasing the probability of two nuclei colliding with each other and fusing into heavier elements. That's what you wanted to do with your neutrinos too, didn't you? You wanted to make them collide better. Proton-proton chain. The simplest reaction that occurs in stars is the conversion of hydrogen into helium, a process known as the proton-proton chain and requires a core temperature of at least 10 million K. In this process, 6 hydrogen atoms, there's number 6 again, which we had with that one design there. 6 hydrogen atoms are needed to create one helium nucleus of 2 protons and 2 neutrons. So proton plus proton, the result is deuterium, positron, neutrino. Then you get a neutrino from there. Proton plus deuterium, helium-3, gamma ray. So you guys need helium-3 because you are looking for helium-3 to make your fuels, but it is toxic. Helium-3 plus helium-3 is helium-4, 2 protons. Table 5.1, proton-proton chain reactions. Okay, so in step 1, 2 protons come together to form deuterium, a nucleus of 1 proton and 1 neutron. This interaction also involves the liberation of a positron, a positively charged electron, and a neutrino. This process occurs 10 to the 38 times per second in the Sun. In step 2, the resulting deuterium nucleus combines with a proton to make the rare isotope helium-3 consisting of 1 neutron and 2 protons. This reaction also produces a gamma ray. In step 3, the helium-3 nucleus becomes a helium-4 nucleus by the addition of a neutron. This step can occur in several ways, but the combination of 2 helium-3 nuclei is the most common way. Steps 1 and 2 must occur twice before step 3 can occur. 6 protons go into the cycle, but 2 come back out. So 4 of them kind of disappear or become. Okay. So basically the 2 that come out, 3 combine in one, 3 combine in the other one, or 4 and 2, whatever. The overall process results in 4 protons, hydrogen nuclei becoming a helium-4 nucleus, 2 positrons, 2 neutrinos, and 2 gamma rays. There's the key. Okay, this is good stuff because this is stuff you're going to use with your some sort of reaction. This helps with the nuclear fusion for some reason. It's got something to do with it. Gamma ray, neutrino, positron. We started with neutrinos at the beginning. We did gamma rays. There actually each of these things, like there's like a whole section of the WOW series that talks about each one, and it's got inventions with it and stuff. And like I said, when you put it all together, going to make something really cool. CNO cycle. In more massive stars, at least 4 solar masses, the carbon-nitrogen-oxygen cycle dominates as the main process for proton burning proton. The heavier elements are already present in the star, therefore largely restricting this process to younger population I-stars. The CNO cycle occurs only in more massive stars due to the necessity of a convective core with a temperature of at least 20 million K. In the process of a 12CS nucleus, and 4 protons combine in various stages, ultimately resulting in the creation of another 12C nucleus, a helium nucleus, and the liberation of a significant amount of energy. The carbon is acting as a catalyst in the process of converting hydrogen into helium. There is no net creation of the heavier elements through this process. So here's the CNO cycle. It's carbon minus 12 plus proton is nitrogen 13, and extras are gamma ray. Nitrogen minus 13 decay is carbon 13 neutrino positron. Carbon minus 13 plus proton is nitrogen 14 gamma ray. Nitrogen minus 14 plus proton is oxygen 15 gamma ray. And oxygen 15 decay is nitrogen 15 neutrino positron. And nitrogen minus 15 plus proton is carbon minus 12 helium nucleus. So you've got 6 different processes, and that's what you get. The future, CNO cycle reactions. The future. Once the stellar core has used up the majority of its hydrogen source, the core region is dominated by helium. The future evolution of the star now depends very firmly on its mass and whether there is sufficient gravitational pressure to induce helium burning and the burning of successively heavier elements. June 13, 2012. Based on the keywords from the data, the formula ideas are as follows. Nucleus plus atom plus protons plus neutrons plus nitrogen atoms plus nucleus helium plus nucleus captures fast-moving proton plus breaks down plus carbon minus 12 plus helium nucleus plus alpha particle plus mass 4. Nuclear fusion plus nuclei plus large number plus protons plus neutrons plus critical temperature. Okay, that's the end of that video. I'm getting on my last little bit of airtime here, so I don't know what I'm going to do next.